Hello everyone, so in this video we're going to be talking about function notation. Function notation is just another way of writing a function. Alright, so we see y equals negative 2x minus 1, so we input an x and we get out a y. Alright, function notation just replaces the y with something called f of x. So this is pronounced f of x. So what that means is I'm plugging in an x and I get out f of x. All right, x is the input. It goes through this function machine here, and we get out an output. Okay, so f of x and y are the same exact thing. All right, we'll just show in some examples why we use this function notation. So, for example, if x was 1, f of x would be f of 1. If f of x was 5, f of x would be f of 5. If x was negative 3/4, f of x would be f of negative 3/4. And then we'll get down in some later problems, but like we can evaluate expressions as well. If x is x minus 4, f of x will be f of x minus 4. So I'm plugging in, like in this example, I'm plugging in 1, and f of 1 represents my output. Okay? So how is this going to work then in these problems? So, example 1, evaluate g of negative 4. So this is saying oh geez, my left hand. This is saying x is equal to negative 4. So everywhere I see an x, I'm going to plug in negative 4. So g of negative 4 is equal to negative, and then I see an x, so I'm going to substitute in negative 4 squared minus 2, and then I see an x, so I'm going to substitute in negative 4, and then I'm going to add 7. Okay? Please remember, whenever you substitute in a number for a variable, put parentheses around it. When you put parentheses around it, that's going to make sure that you're doing all the operations and that you're simplifying correctly. All right? So from here, I'm going to simplify. I'm going to drop down this negative sign. Negative 4 in parentheses squared is positive 16. Negative 2 times negative 4 is positive 8 plus 7. So what this is going to become is negative 16 plus 8 plus 7. And that's going to give me, should be negative 1. So g of negative 4 equals negative 1. What that means, remember, is that if I were to graph this, my x-coordinate is negative 4. My f of x, or my output, would be negative 1. So that is a coordinate that we have. Okay? What about in b? G of x equals 1/2 x plus 7. So I'm telling you g of negative 4. So g of negative 4. Every time I see an x, I'm plugging in negative 4. All right? So 1/2 of negative 4 is negative 2 plus 7. That's going to give me 5. So g of negative 4 equals 5. If I plug in negative 4, I get out 5. All right, let's deal with, in example 2, some different types of functions. And we'll get into what these types of functions are in a little in future videos, but we can still evaluate them using our operations. All right, so h of 1 equals 2, and then all in the exponent, 3 times t, so I'm going to plug in 1 for t, plus 1. All right, so this is going to be 2 to the 3 plus 1, 2 to the 4th. And if you remember, 2 to the 4th is the same thing as 2 times 2 times 2 times 2. All right, so that is going to be h of 1 equals 16. 2 to the 4th is 16. So I plug in 1, I get out 16. All right. And then this in B, we have an absolute value function, okay? And so an absolute value is just, it's finding the distance. So if you ever have a negative inside the absolute value of a negative is a positive. So let's see if that actually happens here. H of 1 equals absolute value of 2, and then I plug in 1 for t cubed minus 3, and then another absolute value sign. All right, so if I simplify what's inside the absolute value, 1 to the third is just 1 times 1 times 1. So that's just going to be 1. 1 times 2 is going to be 2 minus 3, and we close that vertical bar. 2 minus 3 is negative 1. So the absolute value of negative 1 is positive 1. So h of 1 equals 1. Okay? If you ever have a negative sign inside your absolute value, you just take the positive of that. If it's positive, it stays positive because the absolute value is finding the distance, and distance cannot be negative. Okay? So to wrap up this video, what if we wanted to evaluate using expressions? So notice we're trying to find r of negative 7p. So that means every time I see a p, I'm going to plug in negative 7p. What's that going to look like? All right, so we got r of negative 7p equals 5. And then instead of p, I'm going to plug in my input, which is negative 7p. All right, 5 times negative 7p is going to be negative 35p. So r of negative 7p equals negative 35p. All right, we can also plug in expressions. We're just going to get something with a variable at the end. We're not going to get a number like we did in the previous videos. We might not get just a plain old number. All right, and then to finish up this video, n of m equals 4 minus 2m. Find n of m plus 5. So I'm going to take this n plus 5, I'm going to plug it in every time I see an m. So n of m plus 5 equals 4 minus 2, and then I'm plugging in m plus 5. So I need to put parentheses around it. Okay, so to simplify this, I'm going to distribute that negative 2. So I get 4 minus 2m minus 10. Combine like terms now, and I'll get negative 2m minus 6. So n of m plus 5 is equal to negative 2m minus 6. Cannot simplify that anymore. That's just saying when I plug in m plus 5, I'm going to get out negative 2m minus 6. Okay, I know I said that's the last video, but I do want to go over these last ones in this video, and then we'll be done. Okay, given the output, find the input. All right, so let f of x equals 2x minus 3. If f of x equals negative 12, find x. So here I'm not saying find f of 3 or whatever. I'm telling you that f of x equals negative 12. So my output equals negative 12. So I'm going to take that negative 12, I'm going to plug it in for f of x. All right, because f of x and negative 12 are the same exact thing. So I can swap out negative 12 for f of x. So negative 12 equals 2x minus 3. Now I can solve this equation for x. Add 3 to both sides. So I'll get negative 9 equals 2x. Divide both sides by 2. I'll get x equals negative 9 halves, or x equals negative 4.5. Either one, fraction or decimal, is fine. Okay? So if I give you the output, we can find the input. Like in B, given f of x is equal to 2x minus 4 all over 3, if f of x equals 6, find x. So I'm going to take that 6, plug it in for f of x, keep everything else the same, and now I just need to solve this equation. So I'm going to multiply both sides by 3. So I'll get 18 equals 2x minus 4. Add 4 to both sides. We get 22 equals 2x. Divide both sides by 2. We'll get x to equal 11. Okay? So that is a good foundational introduction to function notation. In the next video, we'll deal with how does function notation work when we're dealing with a table or a graph. Okay? Let me know if you have any questions, but make sure you watch that next video.